Our next question is a tricky question. Let's go and see what this question is all about and what you guys needed to do in order to deal with it. Right. So this question is as follows. It says in the diagram below, CGFB and CGHD are fixed walls that are rectangular in shape and vertical to the horizontal plane FGH. Steel poles erected along FB and HD extend to A and E respectively. So you will notice that we do have a rectangular block and another rectangular block there. If I just rewrite that, you'll see that this is the steel pole we're talking about. This long pole that side there is a straight line, which is a straight steel pole, and this one also is another straight steel pole that are holding something together there along the sides of those walls. Right. We are also told that triangle ACE forms the roof of the entertainment center. And then we have BC there equal to X. BC is this distance from B all the way to C. It is equal to X units. We see that X units there. We also see that CD from here to there, the CD length is actually X plus 2. We're happy with that X plus 2, right? And then we were told that angle BAC, that's an angle at the top left corner by A there. That angle you see there is actually equal to theta. We are also happy to see that. And then we were also told that ACE, that angle ACE is 2 theta. We can see that's an angle ACE there, it's equal to 2 theta. Those are good news. We've got enough information to do a lot of things here. And ECD is equal to 60 degrees. So ECD is this angle on the other side here, and it's given to us as 60 degrees. Very exciting stuff. We are all happy to see what we see here. So what's the story? Let's see what's the story here. Show that the area of the roof triangle ACE is given by 2x multiplied by x plus 2 multiplied by the cosine of theta. Right. Now we want you to find the area of the roof. Right. So what I always tell people in these kinds of questions is the way we ask questions might be complicated for a person who doesn't understand how to approach what is happening here. So what you simply need to do is pick the key word in the question. What is the most important word in the question that you are reading? And in this current question that you're dealing with, the key word is the word area. So they want us to find area. I don't care what is going on with everything else that they gave me. What matters is that these people are asking me to find the area of a triangle. Now, for you to be able to do anything on that triangle, you need to have a minimum of 3 things. When you have 3 things that are given, you can calculate anything you're looking for in that particular triangle. And those 3 things must compose of sides and angles. Right, it's very important. So I'm going to go to this triangle they want me to find. I'm going to make sure that it has a minimum of 3 things. If it doesn't, I'll try and see what I can do to make sure that I enrich it by finding at least a minimum of 3 things on it. When I do, then I'll be able to calculate the area of that particular triangle. So now let's go back and see what is going on. The triangle they want us to work on, is this triangle here. It's this one here. The roof. That's the roof apparently. Right. So on that roof, the only thing we know is the angle between side AC and side EC, which is angle 2 theta there. But we don't know the lengths of the sides. And according to the area rule from trig, we can be able to find the area if we know the length of this side here, and we also know the length of the other side on the right, which means if I know how long is AC and I know how long is CE, I can be able to find the area of that triangle. So what I'm simply going to do is I'm going to go to triangle ABC and use it to find the length of AC in order to enrich my triangle. So I'm going to basically isolate that triangle here so that you guys can see what I'm going to do there. We've got B here at the bottom, right, with an angle of 90. We've got an X value there for length of BC. We've got an angle of theta there, and I am interested in finding the length of AC because that is going to help us to figure out enough info for the triangle that we are really interested in. So for me to be able to work out that side, I'm going to acknowledge the fact that what we're dealing with here is we've got a side that is opposite to my angle that is given, and I'm interested in working out the hypotenuse side. So the trig ratio from SOHCAHTOA, we are actually looking at SOHCAHTOA. The trig ratio that will help me to marry the opposite and the hypotenuse is definitely going to be sine. So sine will help me to connect the opposite and the hypotenuse. So what I'm simply going to do here, I'm going to say, okay, the sine of theta is given by the opposite side, which is x, divided by the hypotenuse side, which is AC. And when you apply cross multiplication, your AC is going to simply come out as exactly x divided by the sine of theta, right? And then I'm going to go to my diagram and say, I now know the length of AC. It's simply going to be x divided by the sine of theta. Now I'm going to go to the second part, the other triangle on the far right, triangle ECD. I'm going to do the same thing to try and find the length of EC. So if you allow me to isolate that triangle, right? If I isolate that triangle ECD on its own and then we focus on it, we just zoom on it and see what we can do. It looks like this, right? It's got 60 degrees here. We are given that it's got x plus 2 here at the bottom. It has C here, it has D here, and it's got E at the top. So I'm interested in working the hypotenuse. I want to figure out the hypotenuse of this particular triangle. Again, which trig ratio will help us to do this? This angle, right, is adjacent to the given side, and what we are looking for is the hypotenuse. So the trig ratio, that will help me to marry adjacent and hypotenuse is cos. So we are on K. So I'm going to simply say, okay, fine. The cosine of that angle, the cosine of 60 degrees is adjacent, which is x plus 2 divided by the hypotenuse, which is CE. Cos of 60 is a special angle. You guys should know that this is actually equal to a half. It is x plus 2 divided by CE. And then if I cross multiply, my CE is just simply going to become 2 into that x plus 2 that you're looking at there. Right. So let's go back to our diagram and update it. It's 2 times x plus 2. So we are sitting here with 2 into x plus 2. Now I've got a triangle that is enough information. It has a minimum of 3 things. I've got 2 sides and the included angle. When I've got 2 sides and the included angle, I can apply the area rule from our trigonometry, which we learned in grade 11, and then finish off this question. Right. So let's do exactly that. The area rule says the area of this triangle. So I'm going to say area of triangle ABC. Area of triangle ABC is always half one side multiplied by the sine of the included angle. And in this case, the included angle happens to be 2 theta. Right. That's simply what is going on there. And then I'm going to say, okay, fine. I've got all that I'm looking for because one side there was given to us. We actually found it. It was not given to us. It is x over sine of theta. The other side is simply 2 into x plus 2. Those are the 2 sides that include that angle you guys are looking at there. So if you simplify this, let's see what will happen. Right, let's see what will happen. Half of 2, this 2 here will cancel with that you're looking at there. I'm simply sitting with now x over the sine of theta into x plus 2 times. This is a double angle, and grade 12 should know how to expand the sine of 2 theta. It must be 2 sine of theta multiplied by the cosine of theta. Right, and then from here, I'll then say, okay, I've got sine, which can simply divide off the other sign, and I'm left with 2 times x. So this is simply going to be 2x because 2 multiplied by x, if I just multiply this 2 with that x there, I'll get my 2x. So it's going to be 2x into that x plus 2 you see there, multiplied by the cosine, which is still left there. So I'll write my cosine of theta here. And this is exactly what they wanted us to prove in the question. Right. Let's go to the last part of this question. The last part says if theta is 55 degrees and BC is 12 meters, calculate the length of AE. So we are given the angle theta is 55 degrees. We are given that BC is 12. Okay, fine. Let's go and try and see how this is going to help us here. Allow me to remove everything we've written so far so that we can make sense of what is going on here. We were told that theta is 55 degrees. That means I can now write stuff on my drawing here. I can see this angle is 55 degrees, right? This angle is 2 times 55 degrees, which is going to be 110 degrees here. We were told that BC equals to 12, so this is 12. If this BC is 12, since CD is x plus 2, that makes this one to be actually 14 units. So I've got 14 units there. They want us to find the length of, let's just see, what's the length that they're looking for? They say to us, we need to find the length of AE. We need to find the length of AE. Let's go and find AE. So AE is, again, this distance from A all the way to E. Now, for us to find the length of AE, we are going to use one of the rules. Either you're going to use the sine rule or the cosine rule. But remember, we already found that this side here is actually x, which means it is 12 over the sine of 55 degrees. We found the length of one side. We also find that the length of the other side is simply 2 times. It was 2 times x plus 2, and our x is 14. So, 12. So if I remove 12 here, I'm going to put 12 for x because we know that x is simply 12. 12 plus 2 is 14, and you double 14, you're going to simply get 28. So I'm sitting with 28 as the length of one side in my triangle. So allow me to redraw this triangle with the stuff that we know so far. We know that we've got a triangle that simply looks like this. That triangle has got 110 degrees here. That triangle has got 50, it's actually 12 divided by sine of 55 degrees. It has got 28 this side, and then we're looking for the side that is opposite the given angle there. And you guys will agree with me that the rule that we use if you are in this position has to be the cosine rule. The cosine rule says the line we're looking for, or the side of the triangle that you're looking for, that AE, is always going to be given by the following. So AE squared will be the first side squared plus the second side squared minus 2 times those two sides, and then the cosine of the angle between them. And the cosine of the angle between them is simply 110 degrees. So I'll substitute all that we know so far. We know that this is actually 12 divided by sine of 55 degrees. And the other one is simply equal to 28. And then the next one is 12 divided by the sine of 55 degrees multiplied by 28, and then you just punch everything you see here in your calculator to get whatever the solution that you're looking for. So my final answer, I'm going to need to call my calculator. Remember, a calculator is an instrument, not a monument, so you should use it. Right, I'm going to create a fraction here, which is 12 divided by the sine of 55. Remember to close your brackets, otherwise if you don't close your brackets for your trig ratios, you're going to have a problem. Squared, right? Add that to the second length, which is 28, okay, squared, minus 2 times the first one, which is actually 12 divided by the sine of 55. Close bracket, right? Close that, and then open another bracket for your 28, and then press there. We have got to work out the cosine of 110, which is the angle between those two sides. 2 times 55. You press your calculator, you get 1279 point whatever there. So it's actually 1279 point, come back, let's just see what it is, 0.18. Right, 0.18. But remember, we're not looking for AE squared, we're looking for AE. So remember to take the square root on both sides. So when you take the square root on both sides, by just saying the square root of whatever the answer we have there, we're getting 35.77, right? So it's going to be 35.77 meters, because this was given, first length BC was given in meters, so the final answer will just simply be 35.77 meters. Remember the following, guys: if nobody tells you how many decimal places you need to always pick, it has to always be 2 decimal places, because it was communicated to you in the opening statement. If you read your instructions in your question papers, we always encourage you to round off your questions to 2 decimal places. If it's not specified, it is always 2 decimal places. You will only change it if they tell you how many decimal places they want.